Welcome to a new edition of the Heat Treat Podcast. Today we have a very special guest, Troy Greene from Allied Lock. He's the plant metallurgist. First of all, how you doing, Troy?
Doing great. Glad to be here, Carlos.
So just would like to tell the audience that we've been trying to arrange scheduling for the last 6 months, but fortunately we have Troy. We're going to talk today about quality in heat treat, and with the guy that is actually on the front lines of a manufacturing plant. He's going to tell us a little bit about what he does, the company he represents. But today we're going to talk quality. I mean, on heat treatment, it's a very repeatable process that has very, very tight specs. And we have to make sure that every time that we do it, we follow a certain way, a certain path to meet those specs, right? So today we're talking with the guy that is in charge in the front lines for this to happen. So Troy, can you just tell the audience a little bit about yourself, the company you work for, and what do you do as a plant metallurgist?
Yeah, well, plant metallurgist, I go over the steel specifications, do wear and failure analysis, manage the met lab, manage heat treat, write all of our heat treat programs or cycles. It's kind of multi-tiered because I've been in this industry for 30 years. And so I branch over into wear and failure analysis, design review, design changes, for different applications, as well as heat treat quality in the metallurgical lab and steel purchasing. So it's pretty aggressive.
Okay, so let's start with 101. So everybody that is watching this podcast know what heat treat is, right? So we're heating the steel. We are controlling the temperature in certain time at certain degrees, and then we control the cooling, right? On if we go on a really general statement, right? But when we talk about quality control on heat treat, right? What aspects do we have, first of all, to take a look at? And let's go from very basic to the very technical specifications. So if we were to give 101 to, let's say, a basic heat treat application, what would be like the key things to take a look at? And then we can move forward. So let's start with that.
The fundamentals of a successful thermal process begins with the materials that you're using in the specifications that are being handed to you, be it a commercial heat treater or a captive heat treater. Your materials have to be capable of what's being specified. And going through design reviews has always got to be the first step. And following into that is your process. Once you inspect something after the fact and find out you have an issue, it's too late. So if your process control parameters are correct, then your inspection results at the end begin to narrow down the possible issues that may have occurred for an out of specification part, if that makes sense.
Totally. So you have shared this with us. Can you let us know what are the most common heat treat processes that you perform in your plant, and how do you control those?
Oh, carburizing, neutral hardening. We have carburized oil quench, neutral hardened oil quench, continuous mesh belt, polymer quench. We have atmosphere control, precipitation hardening furnaces, vacuum furnaces for our tool and die department. In relative to the quality control, obviously preventative maintenance, process controls. We use SSI controllers, programmable. We have super data, so we monitor each cycle, each load cycle as it passes through. With that said, we also have operator inspection at the machine. We want them to own their part of the quality. Then we have a back end inspection through our quality control department, Rockwell hardness, Brunel hardness, and then we have the lab. So once daily, at least, we are making mounts, looking at microstructures, looking at retained austenite, transformation byproducts, make sure our cores are transformed. Effective case depths match what we're seeing on a visual total case depth. We do crush tests, bend tests. The labs become quite extensive. And the things that you learn through a good quality metallurgical lab are absolutely astounding.
So you talk about process controls parameters, right? But at the same time, you talked about a bunch of processes with different parameters. You mentioned polymer, you mentioned carburizing, you mentioned neutral hardening, tempering, right? But what will be, everybody talks about time, temperature, right? That will be like the main process parameters, right? But when it comes to polymer, when it comes to atmosphere, when it comes to quenching media, there's some other process parameters that it's quench delay.
Obviously,
how I mean, what should be like the 101 set? I mean, like the key set that you must have. You mentioned that you work with SSI controllers on carburizing furnaces. I know that they measure atmosphere, that they measure temperature, but there's also the thermocoupling, the thermocouples that are on the furnace chamber, on the quench chamber. Is there a little more input on that one?
Oh yeah. Well, for example, you brought up polymer. Our polymer we check daily. A lot of people use a refract. And the way we do it is kinematic viscosity test in a heated tank with a stir plate, and we measure it daily. And we actually use the refractometer to back calculate the difference between the two, so that we know what our contamination within our polymer is. If you follow me,
I do.
And we do that daily. Quarterly, we obviously send out little samples. We send out polymer samples. To validate our processes. Bacteria control in our tanks. We use mold and fungus strips, to see what, possible contaminants or biological issues can be occurring. And that's just with the polymer. The oil, we also do kinematic viscosity. We use DB2000 dew point tests 3 times daily. Quite a bit of checks and balances, to verify that, say for instance, a carbon probe's showing a range of variation, for instance, coming off of 9205 or AC20 controller. And you go out and validate that 2-3 times a day with a dew point check. So you have your digital controls, you have your computer controls, but you go out and physically validate those. And it seems like redundant checks, but it's very important.
And this is my follow-up question. You mentioned the process that you have. There are different processes with different process parameters each, but and you have a repeatable loads, right, with repeatable cycles. How do you ensure that the heat treatment meets the quality and safety standards in your plant? You can have the controllers and the measurements, but how do you ensure that there's the beginning of a tiny spike on the process? How do you ensure that meets quality? Because you see the process that is stable, but when you're looking at trends, you start to see a little spike. When do you say, I mean, I got to check this, or this is under spec?
We check every load. We check absolutely every load. We don't check one load and then run the same program. I know some places do that. We check each load, 4 points in the load. Look at microstructures, look at decarb, because a lot of times your steel comes in already decarburized. And, that ahead of each load, we test for that. We do a lot of testing now to ensure that that finished product is within our specifications and allowances. And yeah, you've got the controls and you've got the monitors, and they're great. They're fantastic. But physically, you have to test those loads. You know, we do tensile, we do fatigue. We have 4 tensile testers, 2 fatigue test machines, MTS machines. We do bend tests. You know, you have to, because if you think about chain, Carlos, one component can cause a 2,000-foot strand of chain to fail. Just one component. So you have to be so cautious and careful to ensure, sorry, there's a fly, to ensure that you didn't just ship 2,000 feet of chain that might have one bad pin, that's not going to make shear, that's not going to have the fatigue life it should have. And so our testing is quite extensive. It has to be.
And now that you have mentioned that, what are the most common challenges that you face in your role as quality manager in the laboratory, in the metallurgical area, in relation to heat treat?
Probably, to be honest with you, when I first came here, these processes were already so vetted. And, you know, they had very, very good procedures in place and very solid heat treatment. Probably the one of the biggest challenges that I face, and I think any heat treater does, is consumables, tubes, combustion tubes, rails, rollers, you know, atmosphere fans, and lead times on these things.
You mean like spare parts?
Yeah, critical spares. And you know, in thinking about that, you have to have critical spares on the shelf, and so you have to plan out. You have to buy something ahead of the time that you need it. Obviously, you have an atmosphere fan failure, or you know you have a quench agitator impeller drop off, or we don't have that, but you just, you know, as an example. But if something like that occurs or blow a combustion tube, if you don't have one on the shelf, then that asset is down for many weeks before, maybe even months before you're going to actually receive a replacement. And you know that plays into the PM. And one of the things that I've tried to stress, you know, at least in my career with metallurgy and heat treatment, is it has to be process driven. It has to be process driven. It can't just be simply inspection. You know, your equipment has got to be right and tight, or your inspection results are going to vary. They're going to change. You're not going to have the consistency that you want.
So you would say that keeping the furnace in shape, right?
Yes.
It's like the most challenging thing on the heat treat shop, on the heat treat operation. I say this because how I see furnaces, I refer as them as self-destructive machines. You know,
they're destroying themselves.
They're destroying themselves every time. I mean,
Yep.
You got well, a lot of heat. You got fumes. You got thermal shocks. You got mechanical movements going in and out.
Yep.
You get a bunch of carbon. You get air sometimes in and out.
Yep.
So you know they are self-destructing itself, and what you want to have is a machine that can be can perform a very repeatable process. And of course, when a furnace is you know, brand new or has just gone through a major repair, it works really nice. But you can start to see how the quality in that furnace decreases.
Exactly.
As time goes in, but it's the nature of the process. So controlling that level of quality to meet the spec while the furnace is getting out of shape of it is you know, breaking out.
That's critical.
It's
absolutely critical.
Is that the first statement? What you're saying? I mean,
yes, yeah. Well, for example, Carlos, we have 6 batch IQs at the moment. We're getting ready to add to that. Of those 6, we run 4, and we have 2 down. And they're going through preventative maintenance. They're going through the battery. You know the battery. We all know the battery is heat treaters. You know, burnouts, cleanouts, roller inspection, rail inspection, brick inspection, archway inspection, door seals, you know, door cylinders. We're always checking these things. Your quench elevator, when so many people fail to pay attention to their quench elevators, that descent into your oil chamber as you're quenching metallurgically could become a nightmare if it's not consistent. And so to back up to what you just said, so we'll have 2 down and 4 up, and then we'll alternate back 4 up and 2 down, if that makes sense. Mm-hmm. The 2 that are ready and they've been proven out will come back up in process, and then we'll take 2 more down, and we have a schedule for that, so that we're not caught off guard as all of a sudden the bung in the atmosphere fans falling out or something. So it's made my life very, very, very easy, because I've got our heat treat supervisors, 37-year man, Dan Cover, and Hank Sin, my maintenance guy, 10 years perfect attendance. I mean, what how much more can you say? And these guys are great. It's like, they're in and out of my office all the time. It's like, hey, we're going to take number 2 down. So we'll bring number 3 up. We go back over to the schedule. You got to work together. It takes an effort.
So production, also quality, because sometimes some furnaces have the PPAP capability to run mm-hmm. itself. Also, the oil type. I don't know if you work with different oil types. It's warm oil, hot oil. So yep. you have to schedule that, and furnaces will also the challenge is that spares on furnaces are expensive. They're a big significant expense. Yep. And if you need to schedule preventive maintenance in order for the life to extend of the furnace, not to have downtime and have corrective maintenance. I don't know if that also contributes to your answer. But having said that, when we talk about heat treat, and you've been around for quite a while, a furnace is just steel box insulated with some burners, maybe radiant tubes. But what are the technologies or advances in the equipment or in your plant that carry out efficiency and accuracy? I mean, heat treatment can go from very, very basic stuff. Mm-hmm. Some heat treaters say, you can heat treat that on a shoebox, right? But there are also a lot of very complex heat treat furnaces and advanced on technology. So it's a very wide range depending on your application. What have you seen in technologies, or how the equipment is moving forward with technology?
Well, digital flow scopes are great. I love the old mechanical flow scopes, but digital flow scopes are absolutely fantastic, because now you can output that data, and you can look at it, and you can see variations in your flow that when we're looking at a real-time chart, for instance, and you're seeing a dip or a slight jump, and you're just wondering, this is a flat line. I like it to be, PV is SP, and it's one straight line. And then you're looking at this like, the little jump is not a problem in the process, but it's irritating, because you want it to be perfect. And you go back out and you take a flow scope apart, clean it. But the thing is being able to track the data, and look at it over time. Look at it over a lot of time, and especially with your endo generators. A lot of people ignore their endo generators because the furnace is the thing that the product's coming out of, right? And you got endo generators that they're like children. They need attention all the time. And you try to take care of these things, and with the outputs that we have now available to us, going back to years when we had carburetors and Allen dew point testers, I look at things now and it's like I can do this with my eyes closed, compared to the way it used to be. But no, the technologies, and particularly in oils, in oil temperature control, in oil level control, is critical. You have to quench in the same volume of oil. You have to have the same expansion. You have to have the same heat transfer, path function. So your parts coming in, that they need to be clean. When they come out of the vestibule, when they come out of the furnace chamber, and you're bringing the elevator down, then so a lot of the ways that we're testing things. You remember the old GM quenchometers, right? Great test. The nickel ball goes, it's magnetic. You got like 8 seconds or something. And now we have the cooling curves that we can do. We have the digitally controlled thermocouple wires and the outputs that we can monitor our oil daily without the little clock on the old wooden box, which is great. I've got one in my office, by the way. But it's part of my decorations.
And we have talked about the heat treat shop, but also on the lab. I mean, we have quality, testing equipment, metallurgical testing equipment in the lab. Do you have an input on that one? I mean, because that has also to be maintained. That's the equipment we use in order to check the results, but as well, that has to be properly maintained, calibrated, and those things are like mini furnaces, because they also break a lot. If you do carburizing, there's a lot of case depth measurements and things like that are also consumables, extensive. Do you have a comment on metallurgical lab equipment?
Oh, absolutely. You need to partner with somebody. I'm not gonna get into brand names.
Sure. But we're not. Just to say, we're not getting paid for that. We're not sponsored.
Right. You need to partner with somebody. And you need to go through the process and make sure that your lab technicians understand. Micro hardness testing, absolutely critical. Mounting, being able to make molds and mounts and cross section, your cutoff saw, making sure that you're not burning your samples. It's added value if it's done correct, and it always will be, because that's what's telling you what's going on with the steel. And I spent a great deal of my time just archiving metallurgy. It's a passion of mine. It's so critical, and obviously, we calibrate our instruments. You have to calibrate your instruments, and I would recommend to anybody quarterly on a micro hardness tester. A lot of people do it once a year. People do what they do, but I would absolutely recommend it quarterly, and because micro hardness is obviously, we do a lot of case carburizing. We do a lot of carburizing. We're moving into carbon nitriding and different things, and we do a lot of induction hardening. And those hardness gradients are critical to the performance of the product, because to the layman that doesn't truly understand carburizing, they'll look at a specification, for instance, that says HRC 60, 65, 0.03, 0.04 depth. Right? So they're assuming that hardness is 60 to 65 down to 0.04 or 0.03. When in reality, you have this hardness gradients to your carburized case. And that's where it becomes critical for the customers to understand, how case carburizing works. And it's also critical to yourself to understand where 50 Rockwell C, your effective case depth's cutting off, what that gradient is, and what the material behind it looks like. Do I have a really well transformed core? Then it all factors in.
Now we talked about quality, a little bit of maintenance, process control, process parameters. So when we come to good size plants, they have a very solid quality system in place, procedures. Heat treat is very repeatable. You know, why do we always have to have a metallurgical guy in the plant besides all the protocols, quality systems, controls, checklists, automations? You talked about electronic flow scope. What role does the metallurgy guy or metallurgical engineer plays in enhancing product quality in your plant? I mean, metallurgy, is not the same as quality, right? But
it's a tough question.
What role does metallurgy plays in quality on an operation?
You're challenging me, Carlin.
Yeah, that's why we invite a smart guest to the podcast. We want to bring the conversation a little up.
Yeah, that's right. All kidding aside, it begins with the fundamental understanding of metallurgy. What are we doing to iron and carbon? What mechanical properties are we looking for? And that has to start with the raw material. What processes are we going to put it through? Are we going to punch it, blank it, stamp it, form it, do cold upset, hot upset, heat treat it, induction harden it? So from cradle to grave with steel, you have to buy that material in the correct condition on the front end. Or at some point through all of those processes, something's going to fail. Or you're going to have more difficulty than you should have. And I think a lot of customers do it to commercial heat treaters. They, anything that you would send out to a commercial heat treater, you should send them at the very least a mill cert, so that their metallurgist can calculate a DI value. They know what type of martensitic expansion and what kind of deformation that they might possibly see. Compare it back to the hardness ranges and the specs that are being specified, because you have all these people that are involved in a design process. So we're kind of the Jedi. We're sort of the control. It's like, hey, respect you, guy, but this is not gonna work. Does that make sense?
It totally does. And whenever I talk to guys that are involved in the heat treat industry, you can tell that they're very passionate about it. You are one of those. When the industry gets you, it gets you forever. That's what I tell everybody. So, Troy, it's been great talking about metallurgy, lab, quality control, enhancement. But now let's talk to the new generation of heat treaters, the new generation of metallurgical engineers, the new generation of material science. You've been around, and you're still pretty young, but you were younger one day, right? If you could give an advice to your younger self, or to the new guy that it's about to enter this industry with furnaces, with steels, with martensite, electronic flow scopes, surveys, thermocouples, that it's going to be all brand new. They don't teach you enough in college about the shop or the application itself. What advice or what personal story or experience would you share with them that you would like to have been shared in 30 years ago?
Most assuredly, be passionate about it. Dive into your ASM books. Consider what you're doing. Consider what you're doing, because you're manipulating steel, not just bending it to your will, but on a molecular chemical level, on all these different. Understand it. There's no more powerful thing than understanding steel. Honestly, being able to understand its properties, get with your maintenance guys. If you're an engineer, get out there and run your equipment, get out there with your operators, get out there with your your department supervisors and your plant managers, and research. Get with your outside commercial heat treaters and learn from them. It's a cliche, I know, but we learn things every day that we didn't know. Constantly learning things from, this heat treat source or that heat treat source, and, they do something a different way, or, but for young metallurgists, most assuredly, you have to understand the work. You have to understand the equipment, and you have to have the respect of the guys out there that do. It's not just math and books. Does that make sense?
It totally does. Thank you so much for sharing that. That was Troy Greene, plant metallurgist for Allied Log. Troy, again, thank you for sharing your passion, your knowledge with the audience. We need more metallurgists, material science engineers like you, because we harden steel, and that's what we do to make the world a better place. Thank you so much, Troy. Did we miss anything else? Would you like to say anything else before we end the podcast?
No, you don't want me to start telling stories, man.
Maybe next time. Maybe we'll get together on a heat treat show or something, and I'll be more than happy to have a beer.
If you're ever in the Chicago area, Dixon's not that far. You got to come see my heat treat, man.
Oh, definitely, I will. So just would like to remind the audience that we're uploading a monthly podcast with power players of the industry as Troy Greene. Have a great day, Troy.
You too.